Hello. Today we are going to talk about how to use rtbricks, which is a freeware that you could use to simulate subscribers. On the channel, I have posted videos earlier about how to configure subscribers using Ixia for DHCP subscriber emulation and PPPoE subscriber emulation. In this video, we talk about how to use rtbricks, which is installed on an Ubuntu machine, and we use that to emulate subscribers. So the diagram on the here is displaying that I have an rtbricks Ubuntu machine with rtbricks installed and ENS19, which is an interface that emulates subscribers, and it is connected to a BNG device. In this case, the BNG device is a Juniper box. There is another interface on this rtbricks which is called ENS20 that simulates a network interface. So we will have traffic from the network interface towards the subscriber emulation interface, which is on the rtbricks. So you will have bidirectional traffic that we are trying to achieve, and at the same time the rtbricks will simulate DHCP subscribers that get terminated on the BNG, and we can check how this works. A pretty impressive tool which can be used to simulate subscribers in situations where you don't have Ixia or any other testing tool. So quickly jumping to the configurations. So the BNG that I was talking about in the diagram has no subscribers at the moment. This is the Ubuntu machine that I have installed rtbricks. As you can see, this is an Ubuntu running 22.4. So the way rtbricks works is you create a config file in this particular format, like a JSON. So I have called the config file as E2. So what I'm doing here is I am enabling multi-threading for my interfaces, which is why you can see the RX threads, TX threads, and all the IO slots. These recommendations can also be found on the rtbrick official website, which has examples on what are the benefits of using these threads. I've just enabled it. Not that I significantly required these performance enhancements for my subscriber, but it is just enabled. Now the key part is you define the network in emulation interface, and in my case it is ENS20, and it is emulating an IP address 20.20.20.3 with the gateway being the router to which this ENS20 connects according to the diagram. So this will be the gateway 200.200.200.1. ENS20 emulates 200.200.200.3. Now the access emulation, the syntax is listed here. As you can see, we have a comment indicating which Juniper box it is connecting to, the interface which is emulating the access subscribers. The type defines what type of subscribers I'm emulating, in this case ipoe, which is DHCP subscribers. The VLAN model is 1:1 because I have stacked VLANs. I don't want IPv6, which is why it is defined as false. The outer VLAN ranges are provided here. The outer VLAN minimum range of 1000 and a maximum range of 1020. Likewise, the inner VLAN range starts from 2 to the maximum range of 4000. Now an interesting definition here is the stream group ID. I am giving a number here, an integer value. This will be called in for traffic generation between the access interface and the subscriber network emulation interface. Now after this, there is another iteration that I start with. What this I1 start value represents is to used for agent's remote ID definition and agent circuit ID definition. So I'm trying to kind of iterate it. So I start with the value of 100,000 with a step count of 2. So what it does is for agent remote ID, it is going to say C 100,000, the first one. Likewise, the next iteration, if I'm going to simulate one more customer, it is going to be C 100,002. Same way for agent circuit ID, it is putting the details with the name that I want along with outer VLAN and inner VLAN. So these values can all be used for subscriber termination, and we are emulating that the access interface is able to send all these details to the BNG. Going further down, the number of sessions I want to emulate is 10, and the maximum outstanding request that the rtbricks can send is 800, and the setup rate of 200. DHCP is what is required in this case, as it is an ipoe, so it is enabled as true. And the stream here defines the traffic I want to send. Name is just a name that you can reference. The stream group ID references the access interface where I've defined the stream group ID. The type is IPv4 because IPv6 is disabled. And the direction is both. So what this signifies is I want traffic originating from the access, terminating on the network emulation interface. Likewise, I want traffic bidirectional from the other side. And the priority is when you want to set task priorities, you can set those values, VLAN priorities, and the packet rate. Now to simulate the particular configuration file on BNG, you just call BNG blaster-c, the config file, and the I is an interactive display of how the sessions are forming. As you can see now, it has established 10 ipoe subscribers. Here it is displayed. And you can also see that the traffic is bidirectional. As you can see, the network interface is sending and receiving 1000 PPS. Access interface is sending and receiving 1000. And the loss you do see here, but they should even out and settle down. As you can see, it's going down. Now, if I were to go quickly to the router, when I do show subscribers, I can see my 10 ipoe DHCP subscribers. They're all terminated and established. And the traffic is running from the access interface to the subscriber interface. So what I have is I have enabled a firewall log to demonstrate that. Now, as you can see, all my subscribers have this block of address range, and you can see that the box firewall log is telling me that I have traffic originating from the subscribers going to the network emulation interface. As we know, it is 200.200.3. Likewise, the network interface is also emulating traffic towards each of the subscribers. So we can see that we have bidirectional subscriber to network emulation traffic originating and terminating from the rtbricks passing through the routers, and the subscribers are also terminated on the box. So this particular configuration file, if you want to terminate it, you press Ctrl+C, and what this will happen is it will gracefully shut down the subscribers, and we expect the subscribers to disappear also from the box. So if I do show subscribers, as you can see, the demux interface has disappeared. Now the VLAN interface will also disappear within a few moments. So the key part here is when we are talking about VLAN model 1:1, you can see that the outer VLAN is 1000 and the inner VLAN keeps on rotating 2, 3, 4, 5, because that's the range we had given earlier on the config file. So starts off from outer VLAN of 1000, the inner VLAN rotation is from 2 to 4000. So now that we have stopped the rtbricks, I expect these values to also disappear. As you can see, all the states for subscribers has been cleared off. Hope this is useful. Bye for now.